Reversing the rules for special products provides us with shortcuts for factoring certain polynomials. And let's take a look at factoring differences of cubes. Consider the following binomial times this trinomial. We'll use distributive property to simplify, giving us the following, which again requires another use of distributive property. And after multiplying, we have the following equivalent expression. Combining like terms, we find an additive inverse of a squared b, which cancels out. Further, an additive inverse of ab squared, canceling one another out, leaving two terms, a to the third minus b to the third, which we call a difference of cubes. To factor a binomial of the form difference of cubes, we will reverse this product to factor. So let's take a look. Is this a difference of cubes? Is the first term a perfect cube? X to the third power. Is 8 a perfect cube? Since 2 to the third power is equivalent to 8, we do have a difference of cubes. We can then reverse this special product with the values that we previously noted, 8 replaced with 2 to the third, and express it in the form here for a difference of cubes, which results in cube root of the first minus cube root of the second. Square of the first term, x squared, here, opposite sign, so we have a plus, product of AB, 2 times x, plus our b squared, negative 2 squared is equal to 4, which gives us our factorization of a difference of cubes. Note that this trinomial is prime and cannot be factored further. Let's look at another example asking us to factor the difference of cubes here. X to the third is certainly a cube, and if you test it, 216 is in fact 6 to the third power. Since it meets the criteria for a difference of cubes, we'll reverse that product for our result in the form of a minus b, the cube root of each of the two terms in our difference of cubes, in other words, x minus 6, times the quantity, first term squared, so x squared is x squared, opposite sign, we have a difference, so we'll have a plus, product of the cube root of each, 6 times x, plus the square of the second term, b squared. Negative 6 squared is 36. And here we have our final factored form for this difference of cubes. Factoring this problem on first inspection, these are not perfect cubes, but we can't forget that we should always consider factoring out the greatest common factor first, which in this case is 2. The resulting binomial is in fact a difference of cubes since 27 can be replaced with 3 to the third power and y to the third is a perfect cube. Establishing that, we'll reverse this special product to factor it with the cube root of the first minus the cube root of the second term times the quantity, square of the first cube root, opposite sign, so we have a plus, product of the two, 3 times y, plus b squared, negative 3 squared gives us a positive 9. We now have our final factorization of this given polynomial.